I don't think kinship selects for a sense of fairness. I'm selected to act nicely towards relatives and to be concerned about their misbehavior and so on grounds of degrees of relatedness. And fairness doesn't obviously come into it, but fairness surely comes into reciprocal relations. So I thought it was also important eventually for a biological understanding of justice. Okay, now, I got a letter from Robert Axelrod, who's a political scientist, and he was going to play iterated games of Prisoner's Dilemma. Everybody heard of the Prisoner's Dilemma in here? Okay, nobody fessing up otherwise. But the Prisoner's Dilemma is a simple game where you either cooperate or defect. If both of us cooperate, let's say both of us get 3. If one cooperates, I'm the fool, and you defect, then I get 0, but you get the benefit of having fooled me, so to speak. If we both defect, then let's say we both get 1. I think this has the proper structure of a prisoner's dilemma. In a single game, we should both go to D, because I'm better off with D if you have C, and I'm better off with D if you do D. So in both cases, I should prefer D, you should reason the same way. We both end up here, and we both forego this. But in iterated games of Prisoner's Dilemma, you can imagine that we might come up with some way to cooperate. Now, there's a mathematical argument that it's not just iterated games, but there must be uncertainty about the end of the iteration. If you know that the game is going to be played 100 times, then you know on the last move you're going to defect. And then because you're going to defect on the last move, you're going to defect on the second to last. And you argue backwards, okay, at least logically. So they added this uncertainty regarding the ending of the game. Now then, the letter said that he was sending this out to a lot of people and asking them to devise a strategy that could win iterated Prisoner's Dilemma. He asked that it be a computer program if possible. I didn't even know how to turn a computer on back then. And I made one big mistake. I thought it was going to be complicated. I thought that you would like to remember back past one move or two. You would like to adjust your behavior to the fact that Doran is now a 70% cooperator, and therefore how should it affect me? And that was a big mistake on my part. And I don't know about the rest of you, but I like to remember my mistakes. I like to sit up and notice. And I sure sat up and noticed here because in came his results, and Anatole Rappaport, who was a game theorist, came up with the simplest strategy. Well, the simplest is always defect. That doesn't give you much. It's a lonely world. You cannot be driven easily out of it. You're all by yourself. Always cooperate is easily driven out by always defect. But tit for tat was the simplest beyond these, and it succeeded. It beat every other strategy put in. So the rule for tit for tat was cooperate on first move and then imitate partner thereafter. Okay? So you start out hopeful in life, and then if the other one's defector, then I'll be a defector towards them. If they're a cooperator, I'll keep cooperating. Okay. So, 2 things were important to me right away. First of all, it was a damn simple rule, and the virtue of that, to someone like myself who likes to see principles in social theory applied as broadly as possible, it can apply to bacteria. You can be a bacterial cell, you put a compound out into the water, which is beneficial to you, but also beneficial to the neighbor. And you have a detector as to whether you're getting back any compound from the neighbor. And if you're not, and the cost-benefit works out that don't make no sense, you stop producing the beneficial chemical. If the individual puts out the beneficial chemical, so the 2 of you now are swimming in sufficient beneficial chemical to make it worthwhile, you keep it up. So you do not need this complex machinery of remembering, well, yeah, what did Doran do to me that day? Yeah, well, why did he stiff me there? And that was a pretty ugly thing he said in the faculty meeting, and blah, blah. We'll add it up and remember costs and benefits going back and somehow extract a strategy. No. One move into the past only, and you could get a workable system. Second thing, by the way, it suggested a novel function for imitation, because I'd always thought of imitation as some kind of learning mechanism, but here you can see that some imitation in us, and it is true in certain aggressive situations that someone will say F you and you'll say F you too. So it's like there's a kind of immediate imitation of behavior that fulfills the tit-for-tat role. Okay. They then showed, Axelrod and Hamilton then showed in a paper that this was an ESS if you gave it a little help at the beginning. When it's very rare, it's hard to get it going. So you've somehow got to get it going in a kin group or going for some reason, and then it'll start to take off. And it'll be an ESS, which cannot be forced out of the game, the well-defined game in which you put it in the first place. So let me just mention a couple of other things that have been done since then, if I can find it. Okay. Now, just two things they've done since then. First of all, they added mistakes. And there's lots of reasons why we make mistakes in life. So if you add mistakes, then tit-for-tatters can be put into a bad situation, where you and I are both tit-for-tatters, but for some reason I defected. And so we now imitate each other, and so we spin through evolutionary, or not even evolutionary space, just our life space, always out of phase with each other. We're two tit-for-tatters, but we're losing all the time. Okay? So this can be protected against by a strategy called generous tit-for-tat, or forgiving tit-for-tat. And it says cooperate on the first move, cooperate on all successive moves if your partner does, but for the defection, every third time you're supposed to defect, cooperate instead, as if you're forgiving them. And that then gets you out of this bind, because you go through a few of these and then suddenly you reverse, and now you're back in glory land together. CC all the way down. Okay, fine. Now, a new game thrives in a world of tit-for-tatters, and it's called win, stay, lose, shift. And so if you win, if you got a good reaction from your move, stay with it. So that means if you defect and the other cooperated, keep with that strategy. Okay? You don't switch to C because the other one did C. You stay with D because that's working just fine for you. But if you lose via D, let's say, then you shift to C. So it's win, stay, lose, shift. And it protects against exploitation, it corrects errors, and it exploits naive cooperators. Those are individuals who just cooperate no matter what, because you'll eat them alive here. It cannot get going in a world where there's many just plain all D individuals. But if the latter have been driven out by the other two, tit-for-tat and generous tit-for-tat, then all C, cooperate all the time, will spread by drift. That's easy enough to show. And then win, stay, lose, shift starts to take off, partly because it's sucking out benefits from all C. Okay. A benefit of all this is that you can do experimental games on it, and so you can mimic the game theory with games that people play in the lab. And sometimes those are very interesting. So we know, for example, the generous tit-for-tat is less cognitively demanding, and that, well, you can prove that 6 ways to Sunday, than win, stay, lose, shift. And sure enough, when extra cognitive demands are made on people in experiments, like they have to do a memory task every other set of tit-for-tat games they play, they shift more towards the cognitively less demanding one. And if they don't, they start doing more poorly on the memory test. Enough. Now I want to turn to deceit and self-deception. And I've got 5.5 minutes with 3.5 minutes left for question. I just, let's see, did this computer ever turn on? Yeah. Well, hell, maybe I'll even remember it. So I've just finished a book, finally, on deceit and self-deception, and the key problem is, why do we lie to ourselves? Lying to the rest of you is no problem at all. But lying to myself, where the hell is the payoff in that? And my basic argument is that it improves my ability to lie to you, and I've organized a world of information around that hypothesis. Now, what about some mathematics on the subject? Obviously, if the better we had mathematics on deception, that would help our theory of self-deception, because it depends on our logic regarding deception. But the logic that's been advanced is either trivial or wrong. Trivial is that the game tends to be frequency dependent. When deceivers are rare, they do well. When deceivers are common, they run into problems. They run into each other all the time, and people are aware of their deception, and so it's frequency dependent. And that'll sometimes lock the roles into an equilibrium where neither is driven extinct. Fine. Then, that's trivial. Now, false logic was the logic that this selection for spotting deception inevitably increases the cost of the deceptive apparatus until the organism can't maintain it, so that truth wins in the end because it drives deception out, because it makes deception more and more costly. Now the model for this is, why don't we have deer running around with paper mache antlers that really didn't cost them much, but have all the ability to fool and impress. And so the argument is, well, you had female choice and male-male aggression on top of it, grinding out to give an honest signal of quality. The only application of this logic that even half works is courtship signals. They will tend to become more expensive over time. But there's no general logic by which deception should be replaced by honesty. But this is a very deep feature of our psyche, apparently. I'm speaking the species now, that we like these damn arguments at the level of the group, or where we end up saying, everything's working out fine, give it time. Selection favors honesty. Just through cost, just relax. It ain't true. Now, what about applying this then to this game theory to deceit and self-deception? Well, a prisoner's dilemma won't work, because if you defect on me, in other words, I tell the truth and you lie, the most appropriate response is usually not for me to tell a lie back to you. It's usually for me to distance myself from you, have less interactions with you, perhaps punish you for the lie, but not mimic you, not lie back. So I don't see any hope for prisoner's dilemma being used to model the evolution of deception. But Carl Sigmund, a mathematician in Vienna, came up with a very clever notion, and he used the ultimatum game. Have any of you heard of that, the ultimatum game? Here's how the ultimatum game works. Someone else, the University of Zurich, puts up $100 and gives it to me as the proposer, and I propose a split to you. And the split I propose is I'm going to keep 50 and you're going to get 50, and you get to say yes or no. If yes, we each get $50. If no, we leave the lab with nothing. And that's how it's played. Okay, so you're going to say yes, of course. But you're going to say yes for 60-40 also. You're not going to give up $40 just because I took 60. But at what point can I drive you down to the thing where you say, F you too, I don't care. And it's 80-20 is when half the people bail out. So I loved the work when I first heard about it, because it was a way of measuring our sense of injustice, because you had to pay for it. So, that my sense of injustice kicks in at 80-20, and then I'm willing to pay the $20 cost to inflict the cost on you. So there's a whole nonsense literature on, what's it called, strong reciprocity, which I'll skip, where again they try to show that all this is for the good of the species. But anyway, Carl, geez, now, I was going to check on, you see, so that I don't want to misrepresent old Carl. Okay, where is Carl here? So Carl proposed a special kind of version of this damn game. And you guys can start asking questions if you want.
What did Carl propose?
What's that?
What did Carl propose?
What's that?
What did Carl propose?
Well, wonderful question. I love you, Doran. Let me see if I can answer. What the hell did Carl propose? Okay. Now imagine a modified ultimatum game in which there are two possible pots, say $100 and $400, and both players know this. Okay? One pot is then randomly assigned to the proposer. So let's say Doran has $100, but I don't know whether he's got 100 or 400. Imagine Doran offers you 40. This could represent 40% of a $100 pot, in which case you should accept, or would be expected to accept. Or 10% of a $400 pot, most people would reject. Okay? Then, he has an unusual step in here that maybe you mathematicians can explain. I mean, it's clever, but I'm not sure I understand it. The proposer is permitted to lie and tell you that the pot is smaller of the two when in fact it is the larger. You can trust the proposer or not, but the key is that you are permitted to pay to find out the truth from a disinterested third party. So I guess I ask you, or Doran it is, and he lies and says it's 400, although that would not be to his advantage so much. It would be the other way around. You'd expect him to lie. And then I can pay now to find out if he's told the truth. This measures the value you place in reducing your uncertainty regarding the proposer's honesty. If you then discover that the proposer lied, you should have a moral or at least moralistic motive to reject the offer, and the other way around for the truth, all compared to uncertainty, i.e. not finding out. Note that from a purely economic point of view, there is no benefit in finding out the truth, since it costs money, after which it may lead to an otherwise unnecessary loss of whatever is offered. The question can then be posed: how much would a respondent be prepared to pay for reducing the uncertainty and go for a possibly inconvenient truth? Note that the game can be played in real life with varying degrees of anonymity and also multiple time, as in the iterated prisoner's dilemma. An ability to discriminate develops, the other person will benefit more from your honesty, quickly seen as such, and suffer less from deception, spotted and discarded. When you add self-deception, it becomes even more complex. I left 1 minute for questions. In the name of Doran Zeilberger and everything that we mathematicians have regard as holy, I give you 1 minute.
Thank you for a great talk. We have 2 minutes for public questions, and Robert will be glad to answer questions in private after these 2 minutes. Any public questions?
So as you prepared for this book, they've observed patterns of deception in chimpanzees, front of the ball down, Yerkes. Does that play into your model as well? I mean, have you compared to other species besides humans and how they behave?
Well,
does it fit within them?
Yeah, there's no comparison of two species, but I'll mention something that goes across all monkeys and apes, and I believe is a general rule, and it's one that I think most of us intellectuals would be surprised at initially and maybe averse to, and that is that if you look at the size of the neocortex, the social brain, or just the size of the brain itself, corrected for body size, across all primates, monkeys and apes, ourselves excluded, here's the relationship between how often they're seen practicing deception in nature and how the relative size of the neocortex. So the smarter you are as a monkey or an ape, the more you lie, not the less. Now children, same thing is true. 4-year-old children, they're put in the following situation where there's a box behind them and the experimenter, and they're sitting there, and the experimenter puts something in the box and shuts it and says, now don't peek, don't look in the box. And then they leave the room and of course watch. Now most children peek. Then they come in and say, did you peek? And most children lie and say they did not peek. But the tendency to lie, again, maps on a simple, crude kind of cognitive ability test, so that if you've got a bright child, 120, they lie 100% of the time. If you've got a slow child, they lie 65% of the time. So contrary to what we might like to believe and imagine is true, I think higher intelligence is associated with more lying and probably with more self-deception. Certainly, certainly probably more sophisticated forms of self-deception, you know. And I think people that are smart and lie tend to have to deny the lying to themselves, and so they're going to practice self-deception right along with it. Anyway, so I've looked at an awful lot of creatures and various kinds of human data, but that's an example of data from other creatures and humans.
Let's thank Robert again. We'll be very happy to answer questions.